Good morning, everyone. Uh, Today I am going to discuss the non-destructive testing. That is the part B of unit number 5. Already we have discussed about the destructive testing. Destructive testings are the uh, testing or inspection methods which are normally used for measuring the mechanical properties of material. While non-destructive testings are the testing methods which are normally used to find out the internal or surface defects in the material. Testing of material without causing any harm to the external and internal structure. In case of non-destructive testing, so no external and internal structure is get destroyed. It does not damage or reduce the service life of the component. Does not directly measure the mechanical properties, and it is normally used to find out the surface or internal defects. So classification of NDT. So already I have discussed that the non-destructive testing methods are normally used to find out the defect, flaws, or irregularities in the material. So two types of flaws are normally detected by NDT methods. So first one is the surface flaws, and second one is the internal flaws. So based upon these two defects, the classification is done. That is detection of the surface flaw, detection of the internal flaws. So if we consider the first classification, that is detection of the surface flaws, of subsurface flaws. So we are having three methods here. First one is the visual inspection, second one is the liquid or dye penetrant inspection, that is also called as DPI or DPT. Third one is the magnetic particle inspection, that is called as MPI or magnetic particle testing also. So these are the three methods under the detection of surface flaws. Now detection of internal flaws. So for detection of internal flaws, some defects which are present in the interior of material that can be detected by using the eddy current testing, sonic or ultrasonic testing, radiography testing. So this is the overall classification of ND. Now first method, that is the visual inspection, that determines the surface or subsurface defects. Now this method is normally used for finding the surface defects. It is a very simplest and basic method of inspection which is commonly used everywhere. So inspection of component is done with the help of naked eyes, or we can use a smaller magnification lens, or we can use one instrument that is called as boroscope. Boroscope. This is the instrument which is normally used for visual inspection. So we can also check the surface roughness by moving the fingers over the surface. It is useful for the inspection of small size components. Only small size component, it is very easy to detect the defects or irregularities or the surface cracks on smaller component rather than the large component. Second thing is defect detection results may vary from person to person. So skilled persons are required for the inspection. Okay, so this is about visual inspection. So visual inspection is the common process which we normally use in many industry for inspection of defects which are present on the surface. Remember that this method is normally used for finding the surface defects or surface flaws. Second method, magnetic particle testing. So, magnetic particle testing is normally used to find out the surface as well as subsurface cracks, or it can be used to find out the surface as well as subsurface defects. So, what is the basic principle? Detection of defects by formation of magnetic poles at the surface. This is the working principle for this process. If a magnet is broken, new poles are created. Iron powder is generally poured on the surface, and it is get attracted towards the defects or towards the cracks, because there will be a formation of poles at the defect, and that's why the iron powder is get attracted towards the crack, and which is generally visible through naked eyes. For any defect present on the surface or subsurface, powder particle will cling to the defect site, and which can be easily detected. So that is the magnetic particle testing working principle. So we will understand this by using this diagram. So this is our test specimen. Let us say the specimen we want to test. So it is having a defect over here. Now we want to check this surface crack. So we'll apply the power supply to this, and we'll try to produce the magnetic field lines. These magnetic field lines will move from south pole to north pole. Now if there is a presence of defect, so this defect will deviate the magnetic lines, and that's why there is a formation of north and south pole here. So if we pour iron powder here, so it is get attracted in this crack. So this crack will attract the iron powder particle, and that's why we can easily see the accumulation of iron powder particles on the crack side. So it is the very easiest method. We can magnetize the material with the help of power supply, and we can easily detect. So what is the limitation of this process? Only ferromagnetic materials can be tested by using this method. Ferromagnetic. What is the limitation? Just we have to use ferromagnetic material for this. You can see there is a vertical crack or the horizontal crack, so that can be detected by using this method. So surface as well as subsurface cracks can be easily detected. So next is we are having two methods here, that is dry method and wet method. So in case of dry method, we use a fine ferromagnetic powder applied on the surface like iron powder. Liquid or wet method, liquid with a ferromagnetic particle suspended in a kerosene or petroleum oil generally spray on the surface, and it is get accumulated on the crack. So there are two methods in this magnetic particle inspection or magnetic particle testing, that is dry method and wet method. In a dry method we use the fine ferromagnetic powder, and in the wet method we are using the liquid with a ferromagnetic particle suspended in kerosene or petroleum oil. So we'll see the procedure for magnetic particle inspection. So first of all, the first step is cleaning the specimen. So whatever the component, we'll first clean the component, and then we'll magnetize the component. Next one is addition of magnetic particles by dry or wet method. We can use both the methods. After that, we'll do the inspection. Sorry. We'll find the uh, where the iron powder is basically attracted. We'll get the location of the crack. After that, interpretation, how big is the crack, or we'll comment on the crack present. And after that, demagnetization. So we have to demagnetize because already we have magnetized that component, and we have to demagnetize it before you actually using that component in application. Okay, so it is the most important, it is the most important process. We have to demagnetize it. So that is also what a limitation of this process, you can say. Now, advantages of magnetic particle testing. What are the advantages? Fast, simple, and inexpensive. It is very simple and fast process. Direct and visible indication of surface as well as subsurface cracks. We can we can find out subsurface cracks also. Subsurface and surface cracks. What are the limitations? Limitations only applicable to ferromagnetic materials. It is applicable to only ferromagnetic materials. Sorry. It is applicable to only ferromagnetic material. You can see. Second limitation, subsurface defects will not always be indicated. So that is the main problem. We cannot find out every time the subsurface defects. Second advantage, unaffected by possible deposits, oil, grease or other metal chips in the cracks. Surface penetration not required. Limitations, relative direction between the magnetic field and the defect line is important. Suppose if we want to find out the horizontal crack and vertical crack, so for these two the process will be different. The magnetic line will play very important role. Object must be demagnetized after the examination. Already I have discussed with you that demagnetization is generally required after application of magnetic particle testing. So you can see some photographs where the magnetic particle testing is performed. So this is the saw blade. So you can see the crack which is present over here. Sorry, I will just use different color. Okay, you just see the presence of crack over here. Here also you can see. So on these two specimen, normally we have applied magnetic particle testing, and you can see the accumulation of iron powder, that is a brown powder, over the crack location. Next process, liquid or dye penetrant testing. So detection of visible cracks or porosity. If we want to find out invisible cracks which cannot be visible through naked eyes, naked eyes. So if it is visible through naked eyes, we'll go for visible inspection. Okay. So if it is not detected, so then we go for either magnetic particle testing or we go for the liquid or dye penetrant testing. So detection of visible, invisible cracks or porosity can be determined by liquid or dye penetrant testing. Component of any material can be tested. So that is the major advantage of this process, because already we have discussed about magnetic particle testing, in which we can use only ferromagnetic material, while in this dye penetrant testing we can use any material. Okay, there is no restriction over the basically specification of material. So in this case dye penetrant is used. Okay, so what is the procedure for dye penetrant testing? So first clean and dry the surface. Apply the dye penetrant on the surface by dipping or by spraying it on the surface. So there is a dwell time we allow to settle down the dye penetrant on the surface, so that it will get in the required crack. Okay, we allow to settle down in the crack. Remove the excess penetrant. Apply the developer, which will pull out the dye penetrant by capillary action. So we are using this developer and the penetrant. So what is the role of penetrant? Penetrant is basically what? It is the shiny liquid, so which can be easily detected on the surface, while developer will pull the dye penetrant by capillary action on the surface. So we can easily visualize the crack on the surface. So first we have to clean and dry the surface, then apply the dye penetrant on the surface by spraying. We allow to settle down the penetrant on the surface, then we'll remove the excess surface from the we will remove the excess penetrant from the surface. Then we apply the developer, which pulls out the dye penetrant from the crack, and it takes the penetrant towards the surface, so which is visible in the ultraviolet or sun rays. You can see this is the first stage, crack not visible on the surface. So we apply the penetrant over here, neither crack or not penetrant is visible on the surface. So we apply the developer over here, so this developer will take out the penetrant on the surface, so this crack can be easily detected in this case. So if we want to see, you can see, just see, first we are having the crack which is filled with the dirt. So we'll first process is what? Cleaning the surface. So whatever the oil or dirt which is present on the surface, it is basically removed, and you can see this crack is now free from any foreign particles. So after that we'll apply the penetrant. We'll apply the penetrant. This is the step number 3, applicant of penetrant. So penetrant will get filled in the crack with the help of capillary action, and after that we'll remove the penetrant from the surface, excess penetrant. After that we'll apply the developer. So if we apply the developer, so after application of developer, the penetrant which is present inside the crack, which is just pulled on the surface. So this is actually a process. First step is the cleaning, second is the application of dye penetrant, third one is removing the excess penetrant, after that application of developer, and after application of developer we can visualize the crack. So you can see here, this is the crack, so which is visible through naked eye.